Okay, so let's wrap up that wordy kind of word problem going on. This time we have to solve a right triangle. We're given the side A and the side B, so the hypotenuse is not known. So again, just drawing a right triangle. I know that C is unknown. We're given the side A, so let me just put that over here, 25, and we're given the side B. Let's call that 32. So here's B, and here's A. So what that also means now is I don't know the angle B and I don't know the angle A. So we have that pretty much running for us. And again, in terms of finding the hypotenuse, probably the easiest thing to use is the fact that we have the Pythagorean theorem. So 32 squared plus 25 squared should equal my C squared. And I am going to reach to my calculator on this one. So 32 squared gives us 1024. 25 squared gives us 625. And so C squared is plus 1024. Sorry, I'm off to the side here. 1649. All right, so take a square root. Again, we've introduced plus minus, but we know it's the positive root. And let's see, 1640. Let's play around with this. 5. Let's just divide that by 3. Nope. 1649 divided by, let's try 6. Nope. 1649 divided by 9. Nope. 1649 divided by, let's say 11. 1649 divided by 13. Nope. 1649. So what's the next? 17. Oops. 1649 divided by 17. There we go, we got it. Alright, so this breaks down into, and what I was basically doing there is going through all my odd numbers. So 3, 5, 9's not really odd, but it's all, you know, one of those odd numbers in terms of doing things. But you saw me try 3, 7, right, 9, 11, 13. I didn't try any 5s or anything like that. But what we have is 17 times 97. So taking a look at both of them, right, this will not break down anymore. All right, so C is this ungodly looking square root of 1649. All right, so there's C. So we really can't do too much about that. So we've got C down. So what about angle A or B? Well, for angle A, all right, for the sides that are given, for the angle A, this serves as the opposite, and that serves as an adjacent as far as side A is concerned. So it looks like the tangent, right, of angle A is the opposite, 25, divided by the adjacent, 32. Okay, and so basically to find my angle A, I need to invoke my inverse tangent function of that ratio. So there is your exact answer. Of course, to get an estimate, we're just going to go to the inverse tangent of 25 divided by 32, and it looks like we get 37.9987. So 37.9877 degrees. So there's my angle A. So far so good. As far as my angle B is concerned, for the angles that are given, right, notice the roles switch, right? So for angle B, this now serves as the opposite, and it serves as the adjacent. So the tangent of B is going to be the opposite, 32, divided by the adjacent, which is 25. So the roles of opposite and adjacent flip-flop for the different angles. So you got to be careful there. Maybe I should have even used a different color. All right, and so what we have then is the B is the inverse tangent of this ratio, right? 32 over 25. Again, there's an exact answer. To get its estimate, I'll turn to the calculator. And so we're basically looking at the inverse tangent, right, of 32 divided by 25. And we get 52.0013. And that would be degrees. right? And of course the idea is if you'd add this to this, you'd end up with 90 degrees because they are complementary. So there you have it. All right, so solving right triangles, whether the right triangle is given to you, right, or whether you have to kind of draw the right triangle to find it. You identify what's unknown, and we're basically using our new definitions. Oops, let me bring them down here. Right, sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent for the angle of consideration. Keep in mind, as we saw, especially down here in this last example, those roles flip-flop depending on your orientation, right? So for A, opposite adjacent. For B, opposite adjacent. So you got to be very careful, right, about where your orientation at and where you're at. So please draw some good pictures, right? Set up your equations, solve your equations, and you should get an exact answer. And then feel free, starting at least from the last section on here, we're busting out our calculators to get some estimates. Alrighty, so that should cover that. We have one more item to cover in 2.4, a little bit of an application problem that deals with solving right triangles. So we'll do that in the next vid.